Hello friends, and welcome to the tutorial on testing and debugging. At the end of this tutorial, you will be able to understand what is software testing, test simple functions for their functionality, automate tests, understand the need for coding style, learn some of the standards followed by Python community, and handle errors and exceptions. Before beginning this tutorial, we would suggest you to complete the tutorial on getting started with functions and advanced features of the functions. Now, what is software testing? Software testing is an activity aimed at evaluating a program and determining that it meets its required results. Let us first write an example simple function to calculate GCD of two numbers. Open an editor and type the following code shown on the slide and save it as gcd.py. Save the file as gcd.py in /home/fossee/path. Now we need to evaluate this function. That is, we have to check whether this function successfully gives us a GCD of two whole numbers. Thus, we need a set of inputs and exact outputs that are expected for those input test cases. Let our test case be 48 and 64 as A and B respectively. For this test case, we know that GCD is 16. So that is the expected output. Let us include code for testing in our file gcd.py and add the remaining lines of code to the file. That is, if __name _ is equal to within single quotes __main __colon. Result is equal to GCD within brackets 48, 64. If result exclamation is equal to 16 colon, then print within double quotes test failed, and then next one print within double quotes test passed. Just now run the script and test our code. We run the code by providing the entire path where the file is located. That is, in the terminal you can type python space gcd.py. We get the output as test passed, which means our code is correct. Note that we have introduced a new semantic which uses two new magic names in Python, __name and __main. This is a very common idiom used in Python. Every Python code in a file can be run in two ways, either as an independent standalone script or as a Python module which can be imported by other Python scripts or modules. When the idiom if __name _ is equal to __main _ is used, the code within this if block is executed first when we run the Python file as a standalone script. In other words, when we run this Python file as a standalone script, the control of the program first starts from the code that is within this if block, after which the control is transferred to other parts of the program or to other modules from here. This comes as an extremely handy feature, especially when we want to test our modules individually. But there can be a number of places where the GCD function might break. Would we have to write a separate test case for all of them? So now pause the video here and try out the following exercise and resume the video. Write code for GCD and write tests for it. Well, that's where automating tests comes in. We can run many tests to check where our code can break. Let's see this with an example. First, let's try an automate test on GCD function. For this, we will write a file with test cases and call the function for all of them. The file structure is shown in form of table here. In the structure of the file will be the two parameters and the output result separated by space. We have separated the elements by a space. We add this code piece to automate the test. So let us now test this code. Open the file gcd.py which we had created before and add this piece accordingly. Now we run it as python space gcd.py. We see that our code has passed the test. So pause the video here and try out the following exercise and resume the video. For the same inputs as GCD, write automated tests for LCM. We shall make use of the same automated test code which we had used for GCD with minor changes. Use the data from the file lcm_testcases.txt. The solution is on your screen. This is the complete solution for your problem. You can test this code by running it on your terminal as we had done for gcd.py. Thus, for any program, there can be innumerable test cases. Hence, practically it is not possible to test cases. However, there are many ideas to reduce the set of test cases by testing those cases that are more likely to show errors. Moving from testing, let's talk a bit about coding styles now. Apart from being able to perform the required task, a property of a good program is its readability. Code is read more often than it is written. This is because that way other people can learn from it and extend and improve it. There are certain pointers for readable code that I am going to discuss. First, naming variables. We choose a name so that it becomes easier to understand its usage. Let's look at this with an example. Amount is equal to 12.68, then denom is equal to 0.05, n coins is equal to round, amount slash denom, then r amount is equal to n coins star denom. As we can see in this example, it is very easy to make what the code is doing. One can almost read it as English sentences. Amount is 12.68, denomination is 0.05, then number of coins is round of amount by denominations. Proper naming also helps us so much in understanding the code. Also, one should keep in mind the following things while writing a code. First one, 4 space indentation, then limit to 79 characters a line, but readability should come first. Functions and methods should be separated with 2 blank lines. The no inline comments, the comments should be above the line they comment. Use docstrings to explain units of code performing specific tasks like functions. Then we should always have white space around operators and other punctuation. Pause the video here and try out the following exercise and resume the video. Give meaningful names to the variables in the following code. C is equal to A/B. The solution is on your screen. As you saw, this will help enormously towards making a program more readable. Now, move on the handling errors and exceptions. Let's try out the following piece of code. So type IPython, then while true, where T is capital, print within single quotes hello world. So what happens when we do this on the interpreter? The interpreter says that this is a syntax error. Syntax errors are caused when we do not follow the rules of the programming language. However, let's try an expression like typing 1/0. Although this expression follows the programming language rules, however, it is not possible to express the solution of this expression. Thus, Python throws an exception called zero division error. Exception is special kind of failure reported by a programming language. Let's see why and how we can use exception in our program. So type IPython, then A is equal to row underscore input within brackets, in double quotes, enter a number colon. Then type a non-numeric input. then type num is equal to int a, you will notice that when you run this program and give a non-numeric input, it throws a value error exception. So now we can catch this exception and write code to handle it. For this we have try and except clause in Python. Let's change our previous code slightly. So type a is equal to row underscore input, then enter a decimal number, then type try colon, then num is equal to int a, then except print within double quotes wrong input and 3 dots. In this piece of code, Python tries to run the code inside the try block, but when it fails, it executes the code block in except. In previous example, we have encountered a problem with running our conversion to integer code. We found out what caused the error and then devised a solution for it. This whole process is called debugging. One can understand the debugging process using the figure. In debugging process, we form a hypothesis of what causes the error. Test if it is correct by changing the code and refine the hypothesis on the basis of our result. Let's see another example of debugging. Create a file mymodule.py and add the following code. So type and create the file. And there you can see the output as like def test function, then total is equal to 1 plus 1, then print span. Let us now try and run this code on the IPython interpreter. So you have to import the file. So type import mymodule, then type mymodule.test function. Interpreter gives us an error because spam is not defined. Let us now do modular debug on interpreter, IPython interpreter. So you can type modular debug and hit enter. The prompt on the shell has changed to IPDB. This is debugger. Here you can access variables in that code block, for example total, unlike the normal interpreter. So you can type total and check. We get the correct output. To exit from the IPDB prompt, press Q. This brings us to the end of this tutorial. In this tutorial, we have learned to create simple tests for a function, automate tests using many predefined test cases, use the Python coding standards, differentiate between syntax error and exception, handle exception using try and except, then use modular debug for debugging from IPython. Here are some self-assessment questions for you to solve. First one, what is proper indentation for Python code according to style guidelines? 2-space indentation, 3-space, then 4-space indentation, then no indentation. Second one, how do you start the debugger on IPython? Debug, then modular debug, then modular debugger, start debugger. Third question is, what is the idiom used for running IPython scripts in a standalone manner? So now we will look at the answers. First one, 4-space indentation is required for writing a IPython code according to style guidelines. Then for the second one, we start the debugger on IPython by saying modular debug. The final question, if __ name _ is equal to, within single quotes, _ main _ colon is the idiom used for running Python scripts in a standalone manner. So we hope you have enjoyed this tutorial and found it useful. Thank you.